All right, so now we're on the second page. So we're going to take what we know about lines and actually apply them to model data. Okay, so the reason we're doing this is because in many day-to-day applications, two variables are related linearly. So I gave you a few examples last time. This means that any given change in an independent variable x will always produce a corresponding change in the dependent variable y. And when you plot this relationship on a graph, it traces a straight line. So that tells us we have a linear function. Okay, so let's look at an example and just jump right in. Number 3, a family plan for a cell phone has a monthly base price of $99 plus $12.99 for each additional family member added beyond the primary account holder. All right, so we got some information. So I broke this question down. So first, we're going to write a linear function to model the monthly cost, C of x, in dollars of a family plan for x additional family members added. Okay, so before we jump in, let's go ahead and figure out what our variables are, what we're going to call them, what they represent. So up here, the independent variable x will always produce a corresponding change in the dependent variable y. So what is our input and what is our output? All right, so we want to model the monthly cost. That's our output. So C of x, whatever we get for C of x is going to be the monthly cost of this plan. All right, so this is our function, what we're getting out. We're putting x in, and what does x represent? Well, x is the additional family members. So something that's always helpful is to figure out your x and your function, which is your y. So you know exactly what you're talking about. Okay, so now we just want to write an equation. C of x tells us the monthly cost. Well, up here it says it has a monthly base price of $99. So it's always going to cost at least $99. And then plus $12.99 for each additional family member. All right, so it's $12.99 for each additional family member. Well, what do we use to represent additional family members? X. So it's $12.99x. So this is our linear function. If you want to make it look like what we've been doing, we can write it so it looks like slope-intercept. $12.99 is our slope. 99 is our y-intercept. And so again, this tells us the monthly cost. And x are the additional family members. Okay, so keeping this in mind, let's evaluate what C of 4 will be and then interpret the meaning in the context of this problem. Okay, so C of 4, that just means we're plugging in 4 into our C. All right, so we can put this in our calculator and we get 150.96. Well, what does this number even mean? Well, 150, that's C of x, so that's going to be the monthly cost. What did we plug in? 4. We're going to have 4 additional family members that will make up that cost. So if you want to write this out in words, you can say, okay, so C of 4 tells us the monthly cost with 4 additional family members. Okay, so maybe we can write in a sentence, the monthly cost of the plan with 4 additional family members. All right, so that's additional family members beyond the primary account holder. I'll write all of this down. Beyond primary account holder. So the monthly cost of the plan with 4 additional family members beyond the primary account holder, well, what is that new monthly cost going to be? It's $150.96. So we evaluated C of 4 and we interpreted its meaning. So this sentence tells us exactly what the 4 means, it tells us what C of 4 means, and it tells us what it is. So maybe this is important. The important pieces of the sentence. All right.